All right, well, here's the last video in our series on weather, and we're going to cover something that can really be dangerous and cause your aircraft to fall out of the sky without much warning, and that is icing. The way we get icing is from two different things happening at the same time. One of those things is having visible moisture in the air, and this could be a light precipitation, um, or a fog or a mist, anything that's visible. Couple that with freezing temperatures, and we have conditions for icing. So we also want to be careful that if we're within a temperature degree or two of freezing on the ground, that remember we're going up into the air, and if there is a normal conditions, there will be cooler air as we rise. So it may be a degree or two warmer at the ground level, but maybe not where we're going to fly. So you want to be cautious because this will cause the water or the vapor that's in the air to stick to the aircraft and freeze. As that continues to happen while you're flying through the air, the more that moisture sticks and creates layers of ice. Number one, the aircraft gets heavier. And that's one way that the aircraft can be brought down, is just by the weight increase by itself. The weight increase is going to cause a stalling speed increase. And normally people get that question wrong on the test because they're thinking of the stall speed decreasing. They're thinking about a decrease in overall productivity of the aircraft and response. And so they're thinking that that lowers the speed, but it actually increases the speed. And you have to think about it like this. The more weight you put on an aircraft, regardless if it's ice or if it's more payload or whatever, now that aircraft is going to have to fly faster to get off the ground or to maintain flight. So, or in the case of a rotary wing aircraft, the rotors are going to have to spin quicker to manage the same amount of lift that's required to keep that aircraft up. I guess you couldn't say that it's really the same amount. It's actually more lift to carry the greater load of the aircraft. So that's one thing. Stalling speed increases because now everything has to go faster. It has to move more molecules over the surface to get more lift so it can hold the aircraft up. So we talked about that being in rotary wing as a propeller stall, and on fixed wing as being a wing stall. It can cause you to have decreased thrust. Now this is what happens when your rotors, or let's say you're flying a fixed wing aircraft with a propeller in front. Now the ice starts to build up on the leading edge of the airfoils, which is your wings or your rotors, your rotor blades. And as it does that, it doesn't flow as smoothly over those blades or wings. And so you're not getting the same quality of airflow over the top of the wing. And it's not creating those forces that normally hold an aircraft up, because it's causing that air to separate from the wing. And it's causing basically an early stall to the wing or to the propeller. And drag. The more ice there is, the larger the aircraft is becoming, basically, and the airflow and the airfoil surfaces, the entire aircraft really is getting larger and maybe bumpier. It's causing more disruption to that flow of air, and so it's going to increase drag. And so this is what ice does to the aircraft, and that's what you need to know. At this point, you're going to go back and you're going to start doing your review in your book. Read the chapter on weather, which is all of chapter 3. And then you're going to go through those questions as you're going through each page. Don't forget to look for the basic why behind the answers. They're in the book underneath each question, kind of gives you that information, and then get ready to take your next test on prepware, and we'll prepare you for the next session. Till then, good studying.